welcome to all for today's session. In this session, we are going to learn about the dual combustion cycle. So, in dual combustion cycle, what are the processes involved in it? Okay, what happens if the processes are different with respect to already studied process called Otto cycle and diesel cycle? What happens? Those are the things we are going to see here. So, in dual combustion cycle, so we should know what is dual combustion. Dual means two, and combustion where the process, that is combustion process happens. If you are applying the fuel, then it is going to the combustion chamber. Then it is the process. Okay, happens. The combustion process happens. Let's see what are the processes involved. Okay. So totally number of processes we should know. First one is adiabatic compression. Adiabatic compression. And 2 to 3, second one, it is constant pressure. Constant pressure, heat addition. And 3 to 4 is constant volume. Just wait here. First, more instances in here, constant volume. Okay, 2 to 3 is constant volume, heat addition. The next one, 3 to 4, this is called constant pressure, heat addition. Okay, so 2 to 3 and 3 to 4, both are heat supply process. So that it is dual combustion cycle. Okay, the first one, first initially it is going, they are supplying the heat by means of volume being kept constant. And then after this process, then the high heat at the same time pressure is maintained constant. Okay. The next one is 4 to 5. 4 to 5 is adiabatic expansion. Okay. And 5 to 1. 5 to 1 is constant volume heat rejection. Okay. By seeing all the processes, we should come to a conclusion with respect to based on what we have learned in the previous classes. Okay. This adiabatic compression process is existing in the Otto cycle as well as in the diesel cycle. In constant volume heat addition process, it is also existing in Otto cycle. Okay. This adiabatic expansion is existing in both Otto cycle and diesel cycle. Constant volume heat rejection, it is also existing in both Otto cycle and diesel cycle. So I can come to a conclusion that this 1 to 2, 2 to 3, 4 to 5, 5 to 1 is same as Otto cycle. Okay, we just replace this 2 to 3, just remove. Then it is also for diesel cycle, and this process also existing in diesel cycle. Constant pressure, heat addition process. Okay. Then 4 to 5, 5 to 1. If you remove this 2 to 3, it is diesel cycle. If you remove 3 to 4, it is Otto cycle. So it is a combination. It is a combination of both Otto cycle and diesel cycle. Okay, you can come to a conclusion on this. And we can have a closed cycle in which we are having 5 processes. So here we can draw a PV diagram. So based on the concept, we can draw a PV diagram. So as usual, initially adiabatic compression. So this is 1 to 2 adiabatic compression process. And 2 to 3 is constant volume heat rejection heat addition process. So this is 2 to 3. Let's say explain this one also. Okay. This is 2 to 3. Here the heat is supplied. So I can say this is QS1, the first combustion cycle. Second one is constant pressure heat addition. Here it is QS2. This is 3 to 4. Next one is 4 to 1. 4 to 1, sorry, 4 to 5 here. This is 4 to 5 other process. This is adiabatic expansion. Finally, we are having constant volume heat rejection process, in which we are having this constant volume heat rejection process. So the point 1 is here, we solve it here. Okay, here we are rejecting the heat. Okay, so based on PV diagram, okay, and for the processes, we can have adiabatic compression and heat supply process here. Here also heat supply process. Here the volume is maintained constant. Here constant pressure is maintained constant. This adiabatic expansion and heat rejection process. Okay, and TS diagram as usual. So temperature versus entropy diagram. So usually we have adiabatic compression. Adiabatic means reversible process. These are all are reversible process. Reversible adiabatic process, isentropic process. So 1 to 2. Second one is 2 to 3. This is heat supply process. So temperature goes on increasing at pressure. And the next one is here also the heat addition process is the second is constant process heat addition. So temperature goes on increasing. Finally, we are having adiabatic expansion. Adiabatic expansion. Okay. So this is 2 to 3. This is 3 to 4. This is 4 to 5. Finally, we are having constant volume heat rejection. The constant volume heat rejection, the temperature drops down. Okay, from here to here. Here to R. So based on the processes and the concept, I have given the TS diagram. Okay, from this we have to find what is the heat supplied, how the heat rejection can be found out. Okay, with respect to these two things, we can find the efficiency. So efficiency is nothing but QS minus QR divided by the total amount of heat supplied. QS means QS1 plus QS2, and QR means where the process 5 to 1 process. So MCV or MCP here is coming under constant volume process. So MCV into T1 minus T5 minus T1. That is the heat rejection. Okay. So accordingly, we have to find the efficiency of the reversible. Okay. We will come to the result of the expression in the next class. Okay. Thank you.